In this video, I'm going to talk about what's called the multiplication principle. You may also hear it referred to as the rule of product, and also sometimes the fundamental principle of counting. Now, if you've ever thought to yourself, I wonder how many license plates are possible, then this is the video for you. So what we're going to do is I'm going to start off with a problem where I'm going to try to fill these two boxes. And I'm going to fill them with one of 6 letters, let's say A through F. Okay, and we can repeat, doesn't matter. So we could have AA, AB, AC, and so on. BA, BB, BC, all the way through to F. And what I want to know is how many different possible combinations of that there are, or different ways that we can put those letters together. Okay, repeating's okay. I can use them all up, and I want to figure out what that's going to be. So the way I kind of think of this is that, first of all, we've got 6 options for the first box. And those 6 options, A, B, C, D, E, and F. So there's 6 options for first box. And then once we've got one of those chosen, for each of those options, so for each option that we have for the first box, each option, there's going to be 6 more options for the second box. Okay, so there are 6 options for box 2. Okay. In other words, if you want to put it in a different way, there are 6 groups. Okay, that's 6 groups. That's the groups corresponding with what you choose to put in the first box. There are 6 groups, and there's 6 groups of 6 options in the second box. 6 groups of 6. Now that's the kind of language we use when very early on in learning mathematics we talk about multiplication. 6 groups of 6 means exactly that, 6 times 6. So 6 times 6 means there are 36 different possibilities for our 2-box problem. Okay, so let's just finish that up. 36 different possibilities. So that means there's 36 different 2-letter box situations. Okay. Now let's bump it up a little bit. We'll move from 2 boxes. I'm going to go to 3 boxes now. 3 boxes. And I'm going to write it a little bit differently this time. So let's think again, we're going to have the same 6 letters, 6 letters, A through F. And when I come to that first box there, okay, just like I did in the previous one, I've got 6 options for the first box. So I'm actually going to pop that 6 inside there. 6 options, that means. Now, for each of those 6, when I come to the second box, there's another 6 options. I've still got letters A through F, so I've got 6 options in there as well. Now remember what we did up here was we said, well, that's 6 groups of 6 options, and that corresponded mathematically with saying 6 times 6. Okay, so now we've got that 6 times 6. In the third box, we've still got 6 letters to choose from. So there's 6 different possibilities in there. So now it's like saying we've got 6 groups of 6 groups of 6 options. So 6 groups of 6 groups of 6 means 6 times 6 times 6. Okay, so that tells us we've got, if you multiply that out, 216 different possibilities. For our 3-box problem, 216 possibilities, or if you like 6 to the 3. If you like this one up here, 6 to the 2. Interestingly, it's the number of different things you can put in the box multiplied by, or sorry, to the power of the number of boxes you've got. 6 to the 2 for 2 boxes, 6 to the 3 for 3 boxes. And you can imagine if I'd have started this whole thing with more letters than 6 or less letters, different number of letters, let's say all 26 of them, we'd have 26 options for the first box, 26 for the second box. So the number of different possible 2 letters that we could put in there would be 26 to the power 2. Down here we'd have 26 to the power 3. Okay, so in the same sort of way of thinking, we could go up to 4 boxes, 5 and so on, but let's just think about this in a smart way. We could have as many boxes as we want. We could have n boxes, let's say, where n can be any counting number. N equals 3, n equals 4, n equals 5, and so on. And the idea here is that we would have 6 to the n different possibilities. For an n box problem. Okay, where n is the number of boxes to fill. And we can combine these things in different ways as well. It doesn't always have to be 6 letters as the only thing that we're putting into the boxes. Like I said at the start, we can think about license plates. So let's take a look at that as an example. Okay, we're going to say in our example here, how many different license plates? How many? And I'm going to say Queensland because I'm in Queensland. How many Queensland license plates can be made? Now in Queensland, our license plates, well, the standard ones have 6 characters. And the first 3 are usually numbers and the second 3 are letters. Okay, so we've got a different sort of situation here. It's not as simple as just our 6 letters that we had up here. We've got a bit of a mixture of things. So different numbers that we can put in there, 0, 1, 2, 3, all the way up to 9. So that's 10 different numbers. So we've got 10 in there for our first box, first character on the license plate. And next one's a number as well, so that's 10. And then a number again. And then finally, we've got letters, 26 letters to choose from, 26 and 26. Now, just like I did up here, okay, 6 groups of 6 groups of 6 is 6 times 6 times 6. Here we've got 10 groups of 10 groups of 10 groups of 26 groups of 26 groups of 26. So we're going to pop some multipliers in there and multiply it out. And assuming your calculator can handle that, we're going to find that the number of distinct plates is 10 to the power 3 times 26 to the power 3, and you should get something along the lines of 17,576,000 different license plates that you can get when the license plates are in that 3-letter pattern. Awesome. Okay, so that's a little bit about our multiplication principle. That's pretty useful in and of itself, but it's also a pretty key part when you come to learning about combinations and permutations as well. So it all feeds into that nicely. All right, so that's it for the fundamental principle of counting, multiplication principle, or the rule of product.